let's talk about another type of inheritance that is related, but spiritually really quite different. And this new type of inheritance is called implementation inheritance. So what we saw before was interface inheritance. And in that approach, the subclasses, they get the signatures of the methods, but they don't get any actual code. So if we look at the list61b interface, we have a signature, but no code. There's the semicolon. Okay. Now Java, for better or worse, allows you to do something called implementation inheritance, where you can actually provide code in the interface, and the subclasses will inherit that code. Okay. So the way we're going to demonstrate this is I'm going to show you how you can write a print method for list61b that will allow you to print any list at all. And the way we're going to do it is we're going to use this keyword called default, which we'll need to use in order to add code to our interface. Okay. So to give you an example of what I mean by why we need the default keyword first, let's say we try and define the method print, like you might naively do, where, okay, I'll say prints out the entire list. And then the print method, we try and write some code. But actually, if you look here, it says interface methods cannot have body. If you add the default keyword, now you can. Okay. So at this point, we can now write a print method. Though it seems maybe a little strange, right? Like a list61b, we don't know if this is an array list or if this is a linked list. Like we don't have a Sentinel instance variable. In fact, we don't have any instance variables at all. So it seems like it might be tricky to write a print method, but we do have all these methods at our disposal, because any method, or sorry, any class that implements this interface will also implement these methods. That's required. Okay. So in this case, we can simply use, for example, our size and our get methods. And we could do something like this. For int I equals 0, I is less than size, I plus equals 1. And this size here refers to whatever size method the implementation has written. Okay. Now we can just print out the ith item by doing get I. We'll add a space for aesthetic reasons. And then at the end, we'll add a new line, also for aesthetic reasons. And now if we go into is-a-demo and we run it, we get a printout of our list, even though the slist class does not itself specify a print method. So if I control F print, there is no defined print method here. There's just a to-do for something we're going to do in the next video. Okay. So this print, I guess to convince you that it's really the list61b class that's doing the printing, if we use the debugger and we run to this line and we step in, we see that we're now running code inside the list interface itself. Okay. So that's actually something pretty new to Java and was impossible until Java 8, which was released in, I think, 2015, something like that, 2016. And so it's a pretty new feature to Java, and it's a little controversial, but be aware that it's out there. It can be handy, though I'll be griping about implementation inheritance here and there. Okay. Here's the method we just wrote, and just the big difference is all of these other methods, you only inherit their signatures. That's implementation inheritance. And here, that's interface inheritance, and this is implementation inheritance, because we get an implementation. So I have a puzzle for you to motivate our next video, which is, do you think the print method is efficient for both A-list and S-list? Efficient for only one of them, or actually inefficient for both? And so on first glance, looking at it, this code looks pretty efficient. I mean, what does it do? It just goes through each item and prints it out. But think very carefully about what the size and get methods would be like for an A-list and an S-list. And I'll pause here and let you think about it. Okay, so turns out that while size will be very fast for both of these classes, it will be slow to get items from the middle of an S-list. So we expect it to be efficient for an A-list and inefficient for an S-list, simply because get for an A-list, I mean, it's super fast. Just get the ith item out of an array. Whereas with an S-list, you actually have to traverse the entire list to get up to I. So we're going to do a constant, just scanning through the list in a very inefficient manner. So if we look at S-list and we look at the get method, for example, we can see that actually involves looping through the array, which is going to be pretty slow if we have to keep looping through the array over and over and over. So in some sense, this is actually a double-nested for loop in disguise. So how do we deal with that? Well, we'll talk about that in the next video.